but we also publish a lot of information on security architecture for software organizations. So today I'm going to be talking about single-page apps. So one of my roles in my job is to teach this architecture and teach the most productive ways to implement security. So really, in terms of an agenda, the use case I'm talking about is secured single-page apps that call secured APIs. And as part of that, I'll talk a little bit about browser threats, concerns, and best practices in the browser, which is quite a hot topic from a security viewpoint. And I'll show that by using an API-driven approach, you can get the best all-round architecture while also implementing the best security. So I'm going to go through a number of slides. At the end of it, I will do a demo as well. And in terms of the content of this presentation, I'm not going to do any really detailed security. You don't need to be a security expert to understand the content. I think most people these days are a little familiar with OAuth and OpenID Connect because they've seen it in other systems, or at least the main behaviors. So I'm going to go ahead and, as the way I always start with single-page apps is to look at the way single-page apps implemented security maybe about a few years ago, 5 years ago, something like that. There was a common model that looked a bit like this. So the single-page app, which may be an app coded in React or that type of technology, would begin by downloading its static content, and then the screens of the app would need to call APIs to get secure data. In order to call APIs, they needed to get an access token, an API message credential. So this would usually involve redirecting the user to log in at an external system. So I think most people have seen this type of behavior. If you sign in with Google or something to access your Gmail, you go to an external system to sign in. And this is very much the OAuth model. After the user's logged in, the browser is redirected back to the single-page app, and the single-page app can call APIs. And this is quite an attractive architecture. There's quite a few benefits to this type of architecture for software organizations. For example, from a development viewpoint, the web developers are working on nice modern technologies such as React or Angular or whatever your preference is. And there's a focus only on the front end. So, in the old days, we maybe used to work with websites and there'd be, the back end and front end didn't always interplay as nicely as we liked. The separation in this type of model is quite good. It makes things quite a bit simpler. For example, the more complex security is handled by the external system. And single-page apps can also be deployed to many locations. There's various ways you can deploy them. One common option is to use a content delivery network that pushes the web content all around the world to like 100 locations or something to ensure good global performance on the website of the architecture. So what's happened in recent years, though, is browser cookies changed a few years ago, and same-site cookies were introduced. And these are stronger cookies, and these days they're considered to have better browser securities and tokens. So, tokens in the browser have more threats around cross-site scripting, and security experts these days recommend that single-page apps should only use the latest, strongest cookies in the browser. This restricts any exploits to, the lifetime of the page, and generally the threats are better understood. And in security reviews and pen tests and things, your app is likely to do better if you're only using the latest, strongest cookies in the browser. So also these cookie changes introduce stricter restrictions on third-party cookies. And when you use OAuth, you use a third-party SSO cookie that the external system, the authorization server, issues. So the original SPA flow, for example, used to have a way of doing token refresh by spinning up a hidden iframe and using the third-party cookies, but that no longer works. And so the only way to get the original SPA flow working reliably in all browsers is to store a longer-lived token, the refresh token, in local storage. And that's really not recommended from a security viewpoint. So essentially these days, rather than using tokens directly in the browser, a different approach is recommended. So I'm sure quite a few of you may have heard of this technique. It's called the backend-for-frontend approach. It involves a backend issuing cookies on behalf of the SPA. And there's a very good document about it in an online document called OAuth 2.0 for browser-based apps. And it talks about, the ways of using a backend component to issue cookies. But the challenge really is not just solving the security problem, it's maintaining all of those original SPA benefits, the developers working only on React, deploy anywhere, simple code, etc. So when you're adding an application cookie layer to an SPA, it can introduce more moving parts, and there's more room for your architecture to become complex and undergo adverse effects. So at Curity, we had to think about the best way to implement a backend for frontend and maintain the benefits of that original SPA flow. And what we came up with is something that we call the token handler pattern. So essentially everything is broadly the same as before, but you plug in two new components. These token handler components, you plug them in the middle between the single page app and the APIs. And I'll say more about how these components behave shortly, but the OAuth agent and OAuth proxy deal with cookies, and they're essentially an application cookie layer that you just deploy and that is called in an API-driven way. And the end results are that you can deploy your single page app anywhere. The cookies it uses are the strongest in the browser. They are first-party cookies, which means these recent cookie restrictions that were introduced don't affect your app. And you're writing the same simple code as previously. So it's worth pointing out in this model as well that this is still a single page app and APIs model, and the APIs still end up receiving the access token, the OAuth 2.0 access token. This allows you to sort of use to do all of your authorization in the best ways to issue this least privileged API credentials. And so the API security is very good, as well as the single page app security. So I'll say more about what these components are in the middle, but essentially the token handler components run on the API side of the architecture, either in an API gateway or just behind it. So let's drill a bit further into what the token handler pattern is and what's different about it. So the differences to alternative solutions, probably the main one is the separation of web host from cookie issuing. So the cookie issuing is done on the API side of the architecture, and that serves the SPA in the best way. It gives you maintains all of the benefits. And when single page apps call APIs, they don't do so via a web backend, they call a high performance API gateway. And so ultimately the token handler components serve the SPA and ensure the best control and usability for the front end. So what's an OAuth agent? So first of all, in terms of terminology, so when we say OAuth at Curity, we mean following all of the recent best practices, use OAuth 2.0 and OpenID Connect together. And what the OAuth agent is just a very simple utility REST API that does the security work. So it does the cookie issuing, it deals with the OAuth logins, etc., in the simplest way for the single page app, and also does other lifecycle things like token refresh and logout, etc. But it's very much a utility API that you can plug in without adding complexity to your business-focused components. So to see how this works, let's have a look at how the login flow works. So when the single page app wants to sign the user in, it makes a simple AJAX request to the login start endpoint, and it gets back an authorization request URL. So those of you familiar with OAuth will know this is the long URL with parameters such as client ID, redirect URI, scope, etc. And the browser then just redirects to this URL at a time that suits the single page app. So, the single page app might save its location and other information potentially, and then it redirects to the long URL. The user is then redirected to the external system and can authenticate potentially in many different ways. The authorization server can enable you to sign in via, passwords or Google or WebAuthn or lots of different ways for the user to sign in, depending on your preferences. And at the end of that process, the single page app receives an authorization code, which is very much the same as the original SPA flow. And this time it sends the authorization code to the login/end endpoint, and all of the right validation checks, all of the OAuth best practices are then followed by the OAuth agent. Once all of those validation checks have passed, the OAuth agent issues the same site strict cookies, and the single page app can then call APIs. So all of this requires very little code, and it's pretty simple for the SPA developers to implement. Let's talk a little bit about the cookie details, because the security is important. So one of the main properties of the cookies issued, so the cookies issued contain the OAuth tokens, and so the tokens are encrypted into these cookies, and the cookies use the same site equals strict property, which provides the strongest protection against cross-site request forgery. And another interesting point to note is that the domain of the cookie is, in this example, is the API domain, which means the cookie is only used when you're calling APIs. You don't need to send the cookie when you're getting, a CSS file or an image or something, because those resources are traditionally don't need securing. So the cookie is very much an API message credential, and that's what it's used for. Let's look at an example cookie here. So here's a cookie containing an access token, and those of you familiar with Curity will know that we recommend that access tokens issued to web and mobile clients should use an opaque access token format. What this means is that the token's not readable, and it doesn't reveal any sensitive information that might be in the access token. Doing so is a privacy preserving best practice. It's some people call these reference tokens, but essentially the front end receives an access token. So when using the token handler pattern, the typical size of a cookie will look similar to this if you're using opaque access tokens. And so essentially the cookie sent to APIs is similar to a web session cookie in older standalone website architectures. It's small and easy to manage. And another thing worth mentioning is that because the cookie is self-contained, you don't need to build any session stores or token stores or anything in the backend. The backend is just stateless and easy to manage. All you do is you deploy the OAuth agent and the OAuth proxy. So moving on to the final component, the OAuth proxy. So like I say, the single page app calls APIs via a high performance API gateway. Depending on your preference, this could be a gateway such as Nginx. It could be a gateway in your cloud system. And essentially what gateways do is gateways enable you to run plugins containing custom logic. And that custom logic can do utility jobs. And the enforcing web security best practices, all of the OWASP cross-site request forgery best practices is something that can be done quite easily in a gateway plugin. If you do it there, then it's very fast to execute because there's no remote calls needed, and also, this code, rather than put all of this security plumbing in your APIs or having to have a web backend, you can just route through the gateway and it does it for you. And as I said earlier, you can plug in a tested implementation from Curity that implements all of the OWASP cookie protection best practices, checking the web origin, anti-forgery tokens, and all of that type of thing is done for you. And also in the gateway, you can introspect these opaque access tokens, so that what happens in the OAuth proxy essentially is that the cookie is decrypted, the opaque access token is introspected, and then a JOT access token is retrieved as a result and forwarded to APIs. So even if you don't get all of the details of that, hopefully the document is fairly self-explanatory, that the single page app sends a cookie, the cookie plumbing is dealt with in the gateway, and the only thing the API needs to do is to deal with the JOT access token. So it's a nice productive model that results in simple code. and the security is externalized from your business-focused components. So what's the end result in terms of security? So essentially what we're doing here in Curity is we're just following the best practices that you would implement in a website as well. So for example, the end result for your single page app would be, so for those of you familiar with the OAuth details, there's some best practices like using a client secret, using proof key for code exchange or PXE, using response type equals code so that no tokens are ever returned on browser URLs. All of those things are done for you. And therefore, the single page app uses website level security and follows all best practices. It's also possible to upgrade the website security to financial grade and use newer standards and stronger options. One example is, you could use a mutual TLS client credential, or you could use push authorization requests, some of these newer standards. So essentially the security is the same as a website or a financial grade website, but it's done in an API driven way that is easy to use. But one thing to be very aware of is that this doesn't solve cross-site scripting vulnerabilities. It needs to be very much part of your application secure application development lifecycle in any JavaScript-based app to protect against cross-site scripting. And follow the OWASP best practices. They've got some very good information on their website. And I think any organization that's doing JavaScript apps is probably doing that. So there's still some threats. If you've got cross-site scripting risks, the malicious code could potentially use a cookie and call your APIs, etc. But it's considered more secure to use cookies and tokens. For example, the malicious code can only call your APIs while the user has the page open. When the user switches page or something, the malicious code would no longer be able to use the cookie. So whereas if you use tokens in the browser, they could potentially be exfiltrated from the browser and sent somewhere to a host or something, a malicious host, where a more concerted attack could be mounted against your APIs. So security in the browser is not perfect, but this is what we believe is the current best options available to you are to use the strongest website level security, and that's what the token handler pattern does. So next I'm going to move on and talk a little bit about deployment, and there's a couple of different ways you can deploy the token handler components. And essentially integrating the token handler pattern is sort of a deployment job. You take a tested implementation by Curity or another provider, and you plug in the components and you connect everything up, and it looks a little bit like this. This is one deployment example. Some people prefer to deploy all of these components behind a single web domain, and the API gateway the API gateway, the OAuth proxy, and the OAuth agent, they all run on the API side of the architecture. In this example, this is done using a /API path, and the static content doesn't have any of this. So this is one way to deploy the system. It's worth pointing out that your APIs and the authorization server, they can be hosted anywhere. There's no limitations there. But this is a common deployment option where everything's under the same web domain. Here's another option where you have two different domains. So in this example, there's a web domain called www.product.com, and this could be a content delivery network that, as I said earlier, pushes the web content all around the world to many locations to ensure local downloads for end users and good performance. And the token handler components can be deployed to a completely separate API domain. So again, the web and API concerns are separated. Again, the APIs can be, the real APIs can be hosted on any domain. So in this option, one thing you need to make sure of is that the web and API domains share the same parent site. Doing so means that the cookies issued are first-party cookies, and they're not considered third-party cookies and dropped by those cookie restrictions I mentioned earlier. So there's a number of ways in which you can deploy the token handler pattern. This is probably the most, probably follows on most naturally from the original SPA flow I showed earlier. One very useful way for the deployment example too, one good option for using this is in terms of developer setups. So some companies may want their developers to continue with the React-only experience that they had before. And because the cookie issuing is separated from the web host, this enables you to deploy all of the token handler components, all of the cookie issuing responsibilities to a remote domain, and web developers don't have to deal with any of that stuff. So this is represented here where the developer uses something like the Webpack dev server, develops in a pure SPA manner using React or their preferred technology. And then in terms of cookie issuing, they connect to remote endpoints like they do for other APIs. So hope this is making sense. If not, there's plenty of information about it on the Curity website where you can read about it more gradually. One final thing I wanted to mention is around splitting up single-page app code bases into sort of smaller apps. Some companies want to do this type of thing where you split a large code base into micro UIs, smaller apps, and you can maybe give different apps to different teams. And this prevents your apps from becoming too large and the code bases, becoming a bit monolithic, And so I think some companies are doing this type of thing. And if you are, then with the token handler pattern, because the cookies are issued by APIs, you avoid the kind of conflict that you might get if the cookies were issued by the apps themselves. So you could have two different apps here, and you'd avoid double logins or one app overwriting the cookies for another app, for example. So the token handler pattern gives you options for sharing cookies when you want to, or isolating cookies if you want to, because it's all based on the cookie domain and the cookie path, and you can set that in different ways for different apps and split up your web code without having to redo your security. So the only thing left to do is a demo, and I'll provide some links also. So the next thing I'm going to show is so we have a code example at Curity. This is a fairly simple single page app, and it's just got some buttons and some actions, and they're explained in the single page app. So initially when you run the app, it doesn't have any secure cookies yet, so you can sign in. There is a pre-shipped user, and I'm just logging in via passwords, but as I said earlier, there's many ways in which you can log in using OAuth, so the architecture gives you many possibilities. And afterwards, I am logged into the app. So at this point, you could look at browser requests and see what's going on and study the messages in more detail. I'm going to call my API here. I can do things like get the OAuth user info to get the username for display. I can work with claims from the ID token, and these are all just simple AJAX calls to the OAuth agent. I can also do things like, open a new browser tab and log out from multiple tabs at once and so on, So the lifecycle events all work very nicely. And as I said, you can run this yourself. There's a Curity repo where, so if you go to github.com/curityo, there's a repo called SPA using token handler. And the thing to notice about this is that the code is pretty simple. All of the cookie complexity is externalized. So this is just a simple React app. It's got some basic views here, which are not very interesting. Probably the only interesting part of the code is the OAuth code. And the OAuth code, as I said earlier, is just simple REST API calls. Let's have a look at a little bit of code here. So the long URL I spoke about before to get the authorization request URL is a simple start to login/start. And when you want to complete the login and get the cookies written, you call the login/end endpoint. So code is all very simple and productive, and the security is externalized, and it enables a productive setup that you can grow. If we go to the homepage of this repo, there's also some links to the Curity website. As I said, we provide many resources on security architecture. So this gives you an overview of the token handler. You can look under the single page app section of code examples to find out more about this particular example, etc. And if you want to know more about the oath agents, there's some implementations there, and the oath proxy is under our gateway content here. So plenty of information if you want to understand this in more depth. And there are some links here to the website I just showed you. There's also a very detailed SPA security white paper. So that's my presentation. That's all I had really. And there's no real advanced security that you need to understand. It's mostly what I've discussed today has been about a separation of concerns to enable the best architecture. So I hope that made sense. Thank you very much for listening, and good luck with your SPAs.